Well, good afternoon and welcome to a webinar about high performance facades. This is our second such event, and because it was well received and we got great questions and excellent attendance, quite a number of people also said because they couldn't make the last one, they were eager to join the next one. So we may make this a regular event. My name is Blair Davies. I run my own company called Façade Systems Inc. And I'm an agent for a variety of systems, including U-Kon here in Ontario and East. I'll introduce Alex, who's going to also join me in the presentation. Alex is the general manager of U-Kon Systems and resides in Vancouver, presently on Broadway in New York, though. Also introduce Luiz Bezerra from Passive House Canada. And I'm going to hand it over to Luiz for a couple minutes, but let me show you this poll, which I think was worthwhile showing to you. So I did it kind of last minute, so I'm not sure if I got representative feedback, but it wasn't that far off what happened in March. So 18%, this is what matters to you about high performance facades and what are your challenges. So 18% was owner expectations, 24% cost, 41% knowledge of what's available. So we're going to hit that today. 18% knowledge of codes. And we're thinking in the future we might have a session about the codes. So think about that, and we'd be happy to receive your feedback on that topic later as well. So with no further ado, I'm going to pull up Luis's presentation, and does that show on the screen, guys?
Yes, sir.
Okay, great. Luis, go ahead and just tell me when you want me to move the screen ahead.
Perfect. Thank you, Blair. I'm just gonna turn it off my camera for fun purposes. Okay, so next slide, please, Blair. First of all, I just want to acknowledge that Passive House Canada acknowledges the ancestral and unceded territory of all Métis, Inuit, and First Nations people that call this land home. Next slide, please, Blair. So as Blair introduced myself, my name is Luiz Bezerra. I'm a senior manager at Passive House Canada. I'm a certified Passive House designer, and I'm proudly to say that I was the project manager of the first certified passive house in South America, in my hometown located in Brazil. So yeah, I'm Brazilian. Next slide, please, Blair. Just to give you a quick introduction, who is Passive House Canada? We are a membership-based social enterprise that we advocate for the high-performance international passive house standard. We do a lot of education and professional development and technical services, and we're also a member-based staff and structure are located all across Canada. Next slide, please. Our mission is to make zero-emission buildings known and adopted by government, industry, and public, to support the government and industry in transition to high-performance buildings through education, certification, and policy development, and to promote the Passive House Institute building standard globally recognized as the best building standard for high-performance buildings. I don't know, just to let you know that why do we focus on this? Just for FYI, 53% of Toronto's GHG emissions are from buildings, 52% of Vancouver's GHG emissions are from buildings, and globally 32% of GHG emissions are from buildings. So that's the reason why we focus a lot on buildings. So Blair, if you want to click twice, so you're gonna have all the informations. But just for you to let you know, the Passive House standard has its roots here in Canada. I don't know if the audience knows this building, but this is the Conservation House in Saskatchewan. And this was one of the houses that inspired the Passive House standard to actually get created. The founders of the Passive House standard, the international one, Mr. Wolfgang Weiss and Bo Edmondson, they came here to Canada and they got some lectures from a gentleman, I don't know if you know them, but Harold Orr, and he's the one actually brought this up. So this is for you to have some information on the standard itself and its history. Next slide, please. So right now, the passive house standard, it's a science-based building physics type of construction. So it can be applied at any type of climate zone. As I mentioned before, I built one in Brazil, so which was a hot and humid. And here in Canada, just FYI, it's the place in the world that grows faster. You know, the amount of square footage built in the world is the second one largest one. We're only behind China, so I consider China kind of to be a little bit of a different market. So what happens is it applies rigorous engineering and principles of building physics to the envelope to reduce energy demand in the first place. It's improved energy efficiency before renewable energy. So the idea is you reduce before anything else. Next slide, please. So it's very appealing to the markets due to the fact that the buildings are resilient, and it keeps the health and wellness all across the year round. One of the things in the passive house is it doesn't matter what is outside, you're always going to have a constant temperature and humidity and air quality inside of your house. Next slide, Blair, please. So it's going to be hard for me to go in only 10 minutes to try to explain as the most that I can about passive house. We do have a lot of education, as I mentioned before, but I'll just give you a high-level introduction to what is passive house. What do I need to know to build the passive house high-performance standard? Next slide, please, Blair. You can click 5 times now. Thank you. So, feel better. This is one of our logos, to feel better, because what you have is you have year-round health, indoor air quality and temperature. You're going to have your house always quiet and comfortable through this changing seasons. Substantial reduction in energy use and operating cost. On this one, I just want to note you that depending to what code you're actually comparing to, you can have a 90% reduction on your costs. It's very simple to use, and you have durable systems and priceless peace of mind, meaning that it doesn't matter if the government decides to put energy up or down, you're always going to have peace of mind that you're not going to be relying too much on that. Next slide, please. So the passive house standard, it uses metrics. You might be asking yourself, what is the difference between passive house standard, LEED, and all the other green standards that you have so many nowadays? What happens is passive house use intensity metrics. It's very simple metrics to implement and compare, okay? And everything that you do, it has to go through the PHPP, which is the passive house planning package, where you energy model everything. So just to give you a brief overview, what your targets are, you have to have an energy demand at tops of 15 kilowatt hour per square meter per year on spacing heating demand. You have to have at the most 0.6 air changes per hours at 50 pascals, the air tightness, and you have the primary energy demand at 60 kilowatt hour per square meter per year. Next slide, please. So the key principles for you to be able to build a passive house are these ones in front of you. So we call it that we have 5 pillars, right? Which is the super installation. You have to have, I like to say that super installation, it would depend on the climate zone you are at. The second one is thermal bridge free design. You have to make sure that you don't have any undesirable thermal bridge in your buildings. You have to have high performance buildings and facade, with good orientation. You have to have an airtight construction. And with all that, you created a very insulated place. So for you to keep the air quality inside, you need a ventilation system with heat recovery. But there's a 6th one right there, which is 4. So the design plays a huge deal when it comes for certification and making sure that you're going to be achieving, the demand and the targets that passive house has. Next slide, please. For example, that is not an optimal form. Don't get me wrong, could this one be a passive house? I'm pretty much sure that you know this building already. I think this one is in Montreal. The thing is, can you do a passive house with this? Yes, you might be able to, but imagine the thermal bridge that you have from every balcony that you have and every overhang that you have. So it's not optimal, but that's the reason why we say that one of the key principles would be definitely, the shape. Next slide, please. So I'm going to talk a little bit briefly about the 5 pillars that I told you about it. So you have to have continuous insulation. For that, you will reduce the heat losses in the winter, reduce the heat gains in the summer, and you're going to have a comfortable interior surface temperature. So for some climates, the R40 would work, but if you go to Alberta, Saskatchewan, Manitoba, the very cold climate in the north of Canada, you probably need a little bit more of insulation on it. Next slide, please. So the continuous air barriers, the air tightness testing, what you do is you reduce drafts, you reduce the possibility of moisture that damages your envelope, and you reduce the heat losses in the winter. Okay, so that you also have a target. And how do you do it is you do a door blower test on the building envelope, and then we normally encourage people to do 2 door blower tests, one in the middle of construction, because it's going to be easier for you to find the leakage, and then you can repair it, and the other one once the construction is over. So you make sure that you don't fail along the way. Next slide, please. The third one is a thermal bridge free design. Thermal bridge, I don't know if you all know, but I'm pretty much sure you do. So thermal bridge is where you're going to have undesirable heat losses that goes through the materials, right? What happens is you reduce having a thermal bridge free design, you reduce the heat losses on desirable ones, and you have high interior surface temperature that prevents damage from condensation and mold. I'm pretty sure that that's the reason why you actually have the heat boards below your windows, because that's your weakest point, and that's where it actually happens condensation, right? Because at 40% humidity, if the temperature goes below 15.6 degrees Celsius, that's where you start having condensations, and it can be due to thermal bridge or due to the air leakage. Next slide, Blair, please. And then you need to have high performance windows and facade systems. So high performance windows add more energy to your home than they lose. Where we are in the northern hemisphere, you have to south oriented most of the windows. So in the wintertime, you capture the most amount of heat that comes from the sun. If you're building on the southern hemisphere of the planet, you just flip, okay? And you actually have also high interior surface temperature that leads to increased occupant comfort. Just for you to know, in a passive house, you can only have a 2-degree difference Celsius, 2 degrees Celsius difference anywhere in the house. If you go near the windows of the facade, you can only go down 2 degrees than anywhere else in the room. So that's the reason why you have this comfort that actually is pretty one of the key things that comes for a passive house. So you actually see that there is a number in there. The U value of the windows is 0.8. But again, as I mentioned before, this will change accordingly to where you are. Next slide, Blair, please. And on the top of that, what you need right now is you need to make sure that you have clean air, right? So you put a mechanical ventilation with heat recovery. The heat recovery in there is just to make sure that you actually warm up a little bit the air that comes from outside, with the one that you have inside of your house. So you're going to need only a very little amount of energy. We're going to talk about this in the next slide. So with this, sorry, Blair, can you go back a little bit? Just so you have to have with a mechanical ventilation system, you guarantee that you're going to have clean, filter, fresh air all year round. You're going to reduce heat losses in the winter, and it controls your humidity. So you have to make sure that your heat recovery has an efficiency higher than 75%. Next slide, please, Blair. And as I mentioned, once you have all of this, you only need a little bit of heat. Can be we encourage at passive house to use electrical. So you can use in many forms of any kind of a post heating that you might need it. But again, it will only depend on the climate zone where you're at. And in the passive house, just FYI, you don't have to have your electric heater boards under your windows due to the fact that you have such a good insulation and air tightness that it can be anywhere in the house. Next slide, Blair, please. And finally, again, you can also use what we have a lot, the heat pumps that actually provides you cooling and heating as well. You know, this is one of the things that right now we do need to have it, even in a passive house. Don't get me wrong, due to the fact that the passive house standard allows you to go over 25 degrees Celsius for 10% of the year. We at Passive House Canada, we stress all of this, and we say that if you have an air source heat pump in your house, you're never going to get anything overheated, and you're going to need only a small one compared to any kind of cold built houses. Next slide, please, Blair. One of the things that I did not mention, passive house is a mistranslation. That passive house in German means passive buildings. So we're not talking about only single family homes. It can be in any kind of climate. So the first passive house was built in 1990, and it's actually occupied since 1991. And we have data collected right now, and you can actually access. If you have any questions, you can put in the chat. I'll be here for more time, and I'll be glad to help. So right now we are at 10,000, and we are in more than 42 countries, from Arctic to tropics. Next slide, Blair, please. And I mentioned before, Canada is the second largest place where you have the highest amount of construction in passive house. But I just want to bring it to you that it's not only for new buildings, but also for retrofits. We in Canada have the highest tower in the world retrofitted, the Kensible Tower, which is actually in Ontario. Next slide, Blair, please. Here are a few examples in BC as well. This one, the bottom left corner, this is an office. It's here in Victoria, and it was finished construction in 2021. You have the Fire Hall 17. It started construction in 2020, and it's supposed to be ready this year. You also have this facility in Pemberton, BC. Next slide. You have also in New York, as Blair said, Alex in New York. So this is Cornell Tech. This is a high performance passive house certified building. You have buildings in Ottawa. You have buildings in Manitoba. You have this one on the right bottom corner, the Subaru car dealership in Alberta. This one is the first of its kind, and it's very interesting because it's the whole car dealership, even where people are working and working on the cars as well. It's also nice to say that passive house can also be modular and prefab, and this is where we believe the future will go. Next slide. You also have Okanagan College and Daycare in Penticton, BC. The Humber College was a retrofit, but they did such a good job that they actually got a certification for a new building. So it was a retrofit, but the job that they did with the air tightness and the amount of insulation they were able to put in, they got a certification for a new building. And this one, the Clayton Community Center, this is in Surrey. This is the first of its kind as well. For those of you who are in BC, I definitely encourage you to go in there and have a look at it. Next slide. More MURBs in BC and in Ottawa, in Austria. The one that you see the heights on the left corner, this one is the first one, the first MURB certified to passive house. There are some lessons learned on this one, and we do also like to share all the lessons learned. I'm not going to go into the details because I only have 10 minutes, and I think I'm almost done. Next one, please, Blair. And right now, what is happening is there's been a competition between who's building the next highest tower in the world. So do you see the one on the left? That's the Balueta. This is in Spain. This is a certified passive house project, and it's the highest one that we have all across the world for now. You see the Cornell Tech. That was the first one before that. And on your right, that's the University of Victoria residences. It's going to be the first of its kind due to the fact they're actually doing a very nice kitchen and living area on the first and second floor. On the third floor, you have the dorms of the students. So it's under construction. It should be ready by the end of this year, if I'm not wrong. And just FYI, the highest passive house tower in the world will be in Vancouver for now. It's I don't know if you have heard about the Alberni Towers. It's going to be starting construction this year, at the end of this year, beginning of the next one. But there's another one already on the works, which is the Earth Tower being designed by Perkinsons and Will. Next slide, please. And last but not least, you have towers of you know, that you use only glazing facade. A lot of people would be asking, if I want to use only glazing facade, is it possible? Yes, it is. You can see this the Vienna one. This is a very interesting project that we can spend hours talking about it. But this one is built to the passive house standard, only works with glazing facade, and it's under operation. You also have the Astro Tower in Brussels, Belgium, that is also just glazing facade as well. And next one, please. I just want to thank you, the invitation from Blair. You know, thank you, Blair, for inviting me. If you have any questions, this is my contact. That's my email. As I mentioned before, at Passive House Canada, we do a lot of education. If you're interested to learn more about being a certified passive house designer, consultant, or if you're a tradesperson, we have the right course from you from the start to the what we call the master classes, which are the postgrad ones. Thank you, Blair, and please let me know if you have any questions. I'll be here, and thank you.
Thank you, Luiz. So there is a question, and maybe if you can see the question bar, you could answer and send everybody the answer. So everybody, we're going to move on to our presentation. There is a question bar and a chat bar, and we're going to keep our eyes on that and stop and look at that every once in a while. So feel free to pose a question. If we get a lot, that's fantastic. If we run out of time, we're going to take all the questions and summarize them and then send them back out to you. Next.
Blair, excuse me, just if you can let the questions as well for us to see it. I just see the chat box, but it's okay. If you can send it to me later on. That's okay. Thank you.
Okay. Well, the question, okay, let me put that in the chat box in just a second. So there's the question, and you can take a second and answer it. So Alex and I are going to present this presentation, and again, we'd be happy to just engage in some conversation. If we can't get through it, that's fine. We have a lot of information, and our intention, although of course we're talking about our systems, what we're trying to do is set your expectation that this is how you should be looking at things. So if we err onto the side of, you know, maybe telling you more about our systems, please take it as you know, our guides and our view on how you get these things done. And I will start away here. So the learning objectives, you can read those. In essence, one of the biggest things we're going to dial into is systems thinking. And I get a lot of questions about a clip, and we'll nail into that quite a bit. There's a lot of work that needs to be done up front to do it right. And we recommend that you work with people that can go do that. And one of the things I see over and over and over again is that people leave the value engineering to the end. And that's not just about subsystems, that's about the whole building. So we recommend that as well. And overall, what we're going to try to do is set some expectations about ways to approach it, but then also go all the way to building buildings. So that's a lot of content in a short period of time. So we had Luiz. So we're into this for a reason, and maybe this sounds a little high and mighty or moralistic or something, but we are. And I was really pleased to meet Alex and learn more of what he does, because it fits nicely into my approach to the marketplace, which is try to leave it a little better than what it was when we got here. Alex?
Yep. Yes. Hi, everyone. My name is Alexander. I general manager of company U-Kon Systems, and our company is design and produce a ventilated facade system. So we constantly working to improve our solution and make them durable, simple, and cost effective. So we provide support and consultation to the architect, the engineer, developer, and installers. And our main goal is to achieve the original design that was created with the budget. So this is why today with the Blair, we will discuss how can we achieve our goals, which factors we have to consider, and when we design the exterior facade, and why the system approach can help us to build the high performance facade buildings. Yes, Blair? Next.
And then, so as part of my list of things I do, this is the line card at the moment, but I've put it together by simply listening to people of what they want and what they need. A lot of I get called in on projects and you're looking to fit some kind of goal, and I try my best to either understand and learn and listen, and then maybe it's find other things that you need in order to meet your needs. So don't limit your thoughts to just that. There's a lot of different configurations and so forth. This is showing a custom terracotta, and it's a recladding approach to things. I had a poll earlier, and I think it lined up with some of these things. We've achieved this list by simply calling folks, and a lot of the folks in the building envelope engineering world, and this number one problem of building what's designed. And they spend a lot of time up front modeling and doing engineering, etc., and then it goes out, and to some extent that loop is open. What gets built, unless you're sitting over the shoulder of the person building it, you don't really know. And there's some ambiguity in the other elements of the business in speccing and constructing. Folks are looking for subsystems that are independent of whatever cladding goes on, simply because that way they can know sub performance aspect of the building envelope without getting caught up with what the exact cladding is. Now there's many players in this space, and this isn't all the people, but one of the key things we're going to get into, and when I get to specification, you're going to want to think about this as a one-stop shop, because otherwise there isn't one owner. And when you're talking about subsystems and design and constructability, you want to know that somebody owns this. Now, there's a lot of factors involved, and one of the examples I wanted to share with you is we have a project going on right now. The cladding contractor, we were brought in very late. The cladding contractor brought us in saying, could you meet $8 a square foot for your subsystem? It wasn't a really high performance building, but what we did, and I give a lot of credit to Alex, is we stepped back from the design and we looked at installation, waste on the panel, what was the architect really trying to accomplish, time, speed, cost of the subsystem, ease to install, and all these various elements. And we were able to come back to them with a price that was higher for the whole subsystem, but in essence saved them a bundle on all these other items, making the whole system less expensive. Alex and I intend to write a document about optimal systems, and we're very interested to hear what your biggest challenges are. Alex?
Yes, the Blair is right. So we have to consider a lot of different factors just for design the one type of cladding materials. But what we have on our building, we have at least 2 or 3 different type of cladding materials, which has their own requirements, like for example, stone, brick, or fiber cement. And using pre-engineered system can help us to increase design speed, to make simple to install it. So in this case, we can specify the one system.
Sorry.
Can you go back? Yeah, it's okay. We just can specify one system for entire project independently from the cladding material, and it's kind of very true. So that many times we use the same substructure system where with different cladding materials with different rates. On the next slide, you can see the project. It's a very simple project at Vancouver Christian School where we use the same cladding material, cladding substructure with fiber cement panels and the metal panel. So one cladding, it's easy to install, and the installer very familiar, and it can be installed faster, and it means that it can be reduce the price of the installation. So can you go next slide? So as I said before, our main goal is to build what is designed. The right thing to do is starting at the beginning, right? So we have to turn the concept into the building. The best thing to do, its initial review, is at the concept stage. On this stage, we can review some main structural requirements for our backup wall, cladding layout, how to make it more efficient, how we can reduce the waste, how we can better budgeting, etc. I'm sorry. Blair, can you go to the next slide? Here's a great example which shows us two different concepts to attach at the same time three-dimensional terracotta cladding materials. On the left side, you can see we use this is a solution that we call like a slab to slab, that we can span it floor to floor. And on the right side, we can use a kind of traditional solution where we attach the wall brackets directly to the steel stud. So what is the difference here, and why is it important? Each solution has their own benefits. So for example, the solution on the left side, like slab to slab, can provide us a lot of flexibility in terms of installation. So we can rely on the concrete floor slabs, and general contractor can use 18 or 20 gauge steel stud because we don't touch them. Also, in this solution, we will increase installation speed, but the price for the entire substructure system will be a little bit higher. On the other hand, on the solution that we use on the left side, it will be less expensive, but with this type of cladding, we have to consider a weight of the terracotta panel. So this is why the structural engineer who is designing the steel stud wall has to consider maybe using a heavier gauge, like 16 gauge or maybe 14 gauge steel stud, to make sure that it can withstand the dead loads and the wind loads. And the installation speed on the solution with the left side will be a little bit lower. So all this factor we have to consider. Can you go to the next slide? Also, if we can produce, if we decided to use the same example and with preliminary calculation, we can determine the performance, the thermal performance of the building, and see right away, can we meet or not the thermal requirements that original design. For example, we decided to use a less expensive solution, but because of the quantity and the layout of the wall brackets, and that create a lot of thermal bridging, we cannot achieve our goals of the thermal performance. So in this case, we have to switch back to the solution that we used before, right? So and for example, if we don't do any the structural calculation, we can and we can go with like slab to slab solution because it's better thermal performance. But can we imagine that we don't do any initial calculation and initial review of the design, and the general contractor decided to go ahead and use a 16 gauge steel stud for the wall brackets, and then they already installed the building, prepared the wall, and the architect and building envelope engineer received the shop drawings from the cladding installer, and they can see all the clip layout on the drawings. And when they check the thermal performance, the existing wall won't meet this thermal requirement. So what we're gonna do? So we have to increase our thermal insulation, or we have to add additional insulation inside of between the steel stud, or we have to switch to the, for example, back to the system slab to slab to reduce it, the thermal bridging. So if we're going to do this, so then we just the general contractor waste some money on the steel studs and so on. So using preliminary calculation, preliminary structural calculation, thermal calculation can help us to see the bigger picture and where we are on very early stage, so that we can make some proper changes. And at the same time, yeah, can you go on the next slide?
I just want to make a comment. The juice on this one is, frankly, when you have a lot of tools at your disposal, you can actually approach the building in rather a bespoke method. And when you're looking for a partner, you want not only that set of tools, but somebody to go figure it out. And Alex has laid out a whole lot of choices and decision making that could optimize the building.
Yes, so, and because we're reviewing the system, not just the wall brackets, we also, on the picture, we can show here that individual components that are using for attach different type of the material. And we also review them separately and then put together as a one system. So, and another slide, you can see a great example that sometimes we can replace the HSS structure with our thermally broken substructure system. It can provide a lot of benefits such as cost, performance, cost, durability, and easy to fabricate on site. And on the other slide, you can see the picture of the using the slab-to-slab solution made from stainless steel or aluminum and compared with the HSS system. Blair?
So there's a lot in the last couple charts, but we want to, dot some interesting designs as well. So this is actually putting high-rise stone in a thermally broken subsystem. We mentioned earlier on in the presentation about systems thinking, and for me, I guess the brown straw engineer, I love this concept because it's been missing in the facade design space for some time. So, folks talk about a component, but when they do that, they risk that the rest of the components are compromised and you don't really get a system. And everything else in our lives, we rely on systems, from airplanes to cars to our houses. But in this case, we've been, satisfied with simply looking at a component. So anyways, taking the systems thinking and breaking it down into building blocks. So on the left-hand side is a range of wall brackets. Some people call it a clip. We think it's more sophisticated to call it a wall bracket. We'll explain why. There's a range of profiles that are connected to those wall brackets, which again are structural, supporting the cladding system. And number 3 is the attachment to the actual cladding. And in some cases, number 2 and 3 are combined, but in other cases they are not. And we're going to discuss them separately, simply because that's easier to get the point across. Now, these are just some examples of wall brackets. And, when you have, again, a toolkit of choices, that means, a design working with you can bring out the system that you want. So I was involved with a meeting this morning. They were asking for 11 inches of insulation. We're involved in a project in northern Manitoba. They want to have R50. And I would say, the systems thinking is anything north of about 6 inches of insulation and easily can be effective down at 4. If you're doing really thin stuff that probably doesn't even meet code, it kind of doesn't matter what you do, but anything that's going to start approaching a performing wall, then you need to start thinking about subsystems like these or wall brackets like these. And one of the questions we inevitably get for the one on the top layer is, does the insulation go into the middle? What we do there is we can cut a slit in the rock wool and slide the insulation around the wall bracket. And of course, it also works well with spray foam. And adjustability is a key factor. Oh, I'm sorry, Alex, but I'll take this one.
Okay.
Sorry.
Yeah, go ahead.
Okay, so you know, a lot of the systems out there, or even just components, allow a little bit of in and out, but that doesn't address all the problems on job sites. So I've been involved with a project or two where the framing wasn't done correctly. I don't know, have you? And I had to stand there and say with the general, you know, we can't accept that wall and that the framing is going to need to be done right before the cladding contractor can do his or her job. When you have an adjustable system on all three dimensions, not only can you deal with the fact of the wall not being straight, you can also speed up construction because you can attach these wall brackets approximately where they're needed and then adjust them separately to make sure that the profiles and the rest of the system line up. So that three-way adjustability is something worth looking at when you're looking for systems. Alex.
Yeah, so yeah, we talk a lot today about the structural performance. Let's discuss a little bit thermal performance of the wall brackets. We all know that different type of material have a different thermal conductivity, which just play a key role in thermal performance. With Immersion Hochschild, we did a thermal analysis where we compare the same design wall brackets, aluminum and stainless, with the same spacing, and but made with as I said, with different materials. And you find out that with the thicker insulation and the smallest vertical spacing between wall brackets, for example, between stainless steel and aluminum, the effectiveness of stainless steel brackets about like 30% more efficient. But with the insulation less than 4-inch and higher like vertical spacing in between the wall brackets, the difference between stainless and aluminum, it's not too big. It's just about like 11%. So in terms of the price, and it depends on your performance of the building, we can make some decision, maybe use a less expensive aluminum wall bracket to achieve our thermal performance, or if we need like a higher thermal performance, we definitely have to go with stainless steel wall brackets. Can you go next slide, please? Also, our wall brackets is Passive House certified, and to make it easy choice for designers and engineers, our company certify our wall brackets according to Passive House requirements. It means that we based on the climate zone, the weight of the cladding materials, you can certify your wall brackets, or it's called in the Passive House Institute facade anchors, in different categories. It can be category C, B, A, and A+ as a component. Can you go next? On the next slide, it's kind of general idea what you can find on the Passive House certificate, and I will try to make a little bit simple and explain all these numbers. So all different manufacturers has to do the same thing as we are. So we have the one facade of the building where we have, based on the structural requirements from the Passive House, we have to lay out all our wall brackets. We decided to do testing for the most heaviest cladding as a stone. So it means we have to install more clips on the wall. Also, we picked the cool temperature climate, which is like, generally speaking, it's our southern border where most of the cities in Canada are located. According to this zone and the concrete wall, we have to use 240 millimeters of exterior insulation. So it means we use our wall brackets, which is like has at least 250 millimeters depth. And then we provide all this information. And Passive House Institute, they did their own structural thermal modeling, and they calculate the total thermal bridging effect, which is called like a delta U, and we achieved the number 0.0164, which lay out as a advanced component because we have the delta U lower than 0.03. So for example, if we're going to use instead of stone, we're going to use like aluminum composite panel, it means the panel is lighter, so we probably can space wall brackets furthermore, which can probably achieve a very advanced component as with the same wall bracket. So
sorry.
Yes.
Before we leave this chart, question is U-Kon approved by Passive House Institute US or just
Germany?
House Institute?
Passive House Institute, because there is just the Passive House Institute in Germany can provide the certification.
There's your answer. And another example of what ventilated facades can be, and an example would be porcelain facades. So we've talked about wall brackets, and now we're going to talk about what's called profiles, and they can be vertical or horizontal. Sometimes they're called girts in the aluminum or in the galvanized steel space. Why do they matter? So first of all, it's about the stiffness to support the cladding, and each cladding manufacturers gives you the deflection that they require. The types of connections to the wall brackets also matter. So if it's going to be slab to slab, it's obviously that you're going to have a beefier profile to handle that kind of loading. And you do basic structural engineering that cladding engineers know how to do. There is a relationship between the stud location and the panel location, and that has to be thought of while you're laying out a wall system. And in some cases, depending on the panel, it's you need a whole lot of design freedom, if you will. In some cases, it's easy to line up with the studs. And what you're looking for is a range of solutions, all the way from light, inexpensive ones to beefier ones. And if you think about it, you could have a light system down at grade and a heavier system up high where the wind loads are higher. And it's if you can get a mix of solutions for any given building, and that's the comment about having a bespoke system for a specific building, and that's going to optimize performance, reduce cost, reduce structural issues, and speed up construction. Now, the relationship between the wall bracket and the profile is important to understand. So cladding systems move, substructures move, the building's moving, and so having the ability to have fixed and floating points in the connection between wall brackets and profiles is important. And that's how the system is designed. And basically, the cladding contractor kind of can't mess this up because of the way the products are configured. Now, this is an interesting innovation too that when I started seeing this from U-Kon, I thought was very interesting. So you have, let's say you have a limited amount of space to put on the wall bracket, maybe at a slab edge, but therefore you want a large wall bracket, but you don't want to have two of them. So you can bring these profiles together, and with fixed and floating points, with a little bit of space between the profiles, you can allow for the expansion, contraction, and movement in the subsystem with only having one wall bracket. Another innovation, we've hinted at it earlier, is connecting slab to slab. And this is really particularly good for speeding up construction and cost, et cetera. But also just think about the benefits of renovation. So if you were to take an existing building and you could put on a lot more insulation, possibly air vapor barriers, and then clad it without having to take walls apart and have the tenants leave the building, the ability to do a deep energy retrofit suddenly becomes much more effective. So, this is a bit of a close-up, and it's a little bit, there's a lot to this topic, and there's a way to design around all the windows, but we're just trying to make things simple. We would have a ability to connect wall brackets and profiles from the slab edge to the slab edge. Pretty obvious. So now you're taking what is 1, 2, 3, 4, 5, maybe times 2 is 10 wall brackets instead of what would have normally been something like 22. I'm pulling those numbers out of my head, but you can think about how many connections need to be made and how many connections have the potential to being wrong. So if you may have to spend a little more money to have a more robust system, but you can speed up construction and improve the quality of the building. This is another example of how different wall brackets are used for different parts of the building and still doing slab to slab. So on the right-hand side might be where the loads aren't as high or the cladding's lighter or you're down at lower parts of the building. And the one on the left with beefier wall brackets allows you to put it, where the loads are a little higher. This is another example of having one wall bracket and multiple profiles and showing you the fixed and floating points of this double cladding wall bracket. And the way that gets done is the first wall bracket goes on, insulation is put over it, and the extender is then attached, making it easy to get the insulation around the component. And, cool building. Just to catch a breather here, doing ventilated facade gives you a whole lot of freedom for the outer skin. And I'm going to stop for a moment and see if there's any other questions. At the moment, it looks like we're cooking along. There was a question earlier that I then copied to chat, but I think what we're going to do is answer that separately.
Okay,
Alex?
yeah, thank you, Blair. So let's discuss a little bit the cladding attachments. As we know, we have a lot of different cladding materials, and also we can install them differently. And mostly we try to design separate them on the visible attachment method and all concealed. And we'll talk right now. We're going to talk about all these both methods very quickly and show what's the difference and some projects that done with all of these different systems. Can you go the next slide? So this is the most common attachment system that using vertical T or L shaped profiles, or sometimes if necessary we using horizontal head track or Z-bar profiles to attach any type of the panels that we have to use rivets or screws. So it can be a fiber cement panel, metal panels, corrugated metal panels, HPL, anything. And yeah, it's very simple. You just has to lay out properly and then touched using the screws. On the next slide, you can see just an example of the project where we use fiber cement panel, corrugated metal panels, and ACM panel at the same system. Another solution that also very common, it is using undercut anchors. So it's like a hidden clip system, like concealed, so you cannot see any fasteners. There's a lot of company that can produce a different anchors like keel, fisher, or like keep nut, and then this system can be used with as the same as fiber cement, HPL panels, stone, porcelain, ceramic panel, anything you name it. It's very simple. So we install the undercut anchors behind the panel with a small kind of hanger clip, and then hanging the entire panel on the horizontal rails. And on the next slide, you can see it's an example of the fiber cement panels installed on the project in Vancouver. Also, and another example of the red panels, these small tiny panels, the architect want to make them similar as like terracotta and without like any fasteners. So we use the same hidden clip system behind each small panels. Another interesting solution to attach, for example, heavy facades like a stone or like a thick ceramic panels, the curve system. It is we use mostly with the stone when we have a top and bottom curve on the edge of the stone, and you again you have like a starter bar, and then you have a middle regular horizontal profile that support the stone, and in this system you can create any joint. It's between like 3-4 millimeters to up to like 12 millimeters thick, very simple to install. But we have some limitation in terms of the size of the panel, the thickness of the stone. We probably can use maximum about like a 2.5 inch thickness of the stone. And on the next slide, it's the project we finished in Victoria, BC. There's like a limestone panel installed on this apartment building. You can see we use the same solution to attach the soffits, also the cornices done using the same solution. Can you go next? So the next slide, it's also very interesting. We created like a solution that has the aluminum frame that can be installed inside any type of the materials. We can install like a thin ceramic panel, you can install glass, or even you can install this the solar panel. And on the next slide, you can see the example of the project in Sweden, done like in 2012, one of the biggest apartment buildings using the solar cell panel. This is what we talked before. As a passive house, you have to design as a form and arrange the building specifically. If this type of the building architect oriented the building on the south, so that all this the solar panel can catch all the sun. Can you go next? At the same time, we have some solutions like thin brick veneer, for example, a corium or like a smart clinker. There's a which is like create like a horizontal rail and help us to install like individual clinker veneers separately. The nice solution about that, you can get exactly the same look as a brick, full brick size, but then the system is lighter. It means that you have a fewer low brackets, so it's you can make a better thermal performance building. Can you go next? Yeah, it's an example here. Some projects done with the brick. On the next slide, it's a corium materials that installed vertically. So with this solution, you can go vertically or horizontally, so it doesn't matter. So it provides you a lot of flexibility. On the next slide, you can see this solution for terracotta panel. There's a lot of manufacturers who produce a terracotta, for example, Agriton, and we have solution to attach this Agriton panels horizontally or vertically. It doesn't matter. It just we have to change a little bit some profiles and clips. And on the next several pages, you can see some examples that even some manufacturer can produce a curved terracotta panel, so that if you want to achieve some curved surfaces, it's possible to do. Blair, next. Yeah, this is an example with the terracotta panels.
So I'm going to talk about specification for a moment, and I'll admit some guilt here. I was involved with writing some of the specs for Division 7 claddings almost 10 years ago, and I wrote in you know, a paragraph or even a few lines about a clip, thinking that was the right way to do it. It's not. There is, you know, sometimes what you see is people writing in the depth of the clip. Sometimes you see that in the drawings, but it still doesn't say what's going to happen. There's nothing in there about inspections or how to accept review or expectations on shop drawings. And even recently, I read some specs where the clip was tied in with specs on the trims and the bird screens and the air vapor barrier. So not good, old, not the right way. And I'll explain that in a moment. So what you're looking for, and I've had conversations with a number of the spec writers, is to pull that, you know, paragraph or two and pull it out and create a new subsystem spec. And that can be used for the entire building, because he showed you some examples where you had metal panel and fiber cement, for example, and why wouldn't you have one subsystem? In that, you can be very specific about the vendors. I'll talk about that in a moment. You can be not only talking about, what depth, because somebody did their engineering, but you can also talk about the performance, so that the folks getting the order have to be meeting the performance. You can spec all of the business aspects of it with mock-ups and inspections and how long the people have been around in the marketplace and that kind of thing. And this last comment, well, third last, is this tight connection between structural thermal engineering. That doesn't get done. And I've talked to a number of building envelope engineers that, they do their work up front, and then when it gets on the building, they don't know. And it doesn't come back to them in order to do a full thermal analysis after the structural engineering was done by the contractor. So the spec that we recommend is that the structural and thermal work be done by the manufacturer. And to try to make the point, this is the length of our spec. And as I mentioned at the very beginning of the presentation, of course, we're telling you that we're the right people to work with, but I also recommend a couple things. And I just picked a few things out of the spec, and you can read it, and you'll see the depth and comprehensive aspect of this specification. So I got 3 ideas for you. One is, of course, love those U-Kon FSI people, take their spec and run with it. Okay, sounds good. Probably not the way you have to service your clients, though. So the next 2 would be add in vendors who can do this systems thinking, do engineering, do thermal work. And we do have competitors, and you can put approved vendors in this list. Or you can make it a performance-based spec and put no vendors in, and you can use this as a template, add things, subtract things, in essence, put it out as a comprehensive spec that everybody needs to meet. So 1, work with us directly, and 2, add on approved vendors, or 3, take everybody out. And frankly, we'll work with you on that whole design assist approach, whether, whatever design or whatever idea you have for the spec. And then post-award, this is the kinds of things that should be the standard. And this is the expectation that you should have when things go forward. And that's the purpose of having this in the spec too. So you should be reviewing drawings that were directly from your model. So the contractors should be getting your model, and then their drawings should link to the model. The design in both the components and its performance should come from that model. Should be a comprehensive approach. We recommend, especially on any kind of building that has some complexity, is that a mock-up support system be built on the job site or possibly separately, so that everybody knows what they're going to get and what the expectation is on building the system out. And it's at that stage any risks and overages potentially get talked about. Maybe there's parts of the building that have access issues. Well, that's the time to bring those up and satisfy them. And maybe that happens even through the walkthrough at the bid process. Now, the expectations for the contractor, this is probably beyond what is the current status quo. So some of my friends in the contractor world maybe won't be happy with me directing this approach to things. But again, the shop drawings should directly come from the architect's model. They shouldn't come from the last project's shop drawings. And that comprehensive link is going to make sure that the building's actually going to do what it was designed. The fabrication support, so laying out holes and anchors and cut sizes should come from that comprehensive approach to things. The contractor should be considering the cladding and the cladding supplier. There should be maybe I put prefabricated optimal length, but another simple word for that would be kitting. so that when the cladding contractor receives its subsystem, it gets the right number of types of wall brackets and profiles, etc. Again, I think the cladding contractor should see doing a mock-up as a good thing, making sure that everybody's on board with what they're going to go do. And a key part of this, and part of the thing that we like to be involved with up front, is this panel layout optimization. Because again, if you're going to do it at the end, this is when problems happen. And the problem that we see is eventually you do get the panel layout optimized, but it took weeks and weeks and weeks to get it there. And lastly, in retrofit businesses, pull-out tests on anchors is an obvious one, and that should be in the spec for the contractors. I'm going to just answer some questions, Alex, before we go to the next one. So a couple of the questions. Residential slabs are often quite thin. Is it difficult to install enough anchors maintaining the clearance from the edge of the concrete? So the answer to that question is it's engineering. And if the slab is so thin that where there are heavy loads, sorry, Alex?
Yeah, I mean, it's possible. We just, for example, the clip we have, we can install like 2 anchors or 1. So for example, this slab, like let's say like 150 millimeters, and it's allowed just install like a 1 anchor, and we also can use like a chemical anchors that a little bit better work on the edges. So we just has to look at what is the chemical requirements of the anchor, and then we just can create figure out what's the depth of the anchor to meet the pullout.
That
yes, it's possible.
The other comment I'd have is, you don't have to have one system for an entire building. You could have slab to slab where the loads made sense and the pullouts made sense. But if you had to go to a distributed system where maybe the loads are heavier at higher elevations, etc., then you could do that too, all in the same project. Next question, do you offer prefabricated wall panel systems? This is a real touch point for me. I was in a meeting even this morning on that topic. I believe Ontario needs to move ahead on prefabricated wall systems. They're being done elsewhere. And I'm trying to take all of the systems that I have into that space. But I have to tell you that Ontario is a bit behind with getting these in place. So I'm now in conversations with 2 companies for a fairly large project. And I think if we can crack this in Ontario, we can, stir this ahead very, very rapidly. It's not something that hasn't been done elsewhere. It is definitely leveraging engineering that has been done prior to Ontario. Alex, there's a question here about how long wall brackets last before they deteriorate to the point of failure.
So the wall brackets almost last forever. We use an aluminum alloy 6063 or 6060, which is in France. They were done some aluminum railing installed like 100 years ago, and they still looking for this alloy, and there's no degradation. Or if we're going to use a stainless steel wall brackets, which we use like a 304 or 316, which also can last forever. So it can last for a long time.
And the last question, can we get a copy of the spec? So all of the specs for all of my products are on my website. They're in 2 places, one in the U-Kon page of the website, or there's a 1 page that has all of the specs for all of my products. So you're welcome to have them. And obviously I can help you with how to edit them as you see fit, but they're all there for you to use. And then Alex is going to tell you about a nice little job to explain some of the points we're discussing today. Alex?
One sec, my microphone was off. So just want to explain very quick what we've done here. We received a call from excavation company that was done like doing this like a pump station, and they're looking for the cladding and the system to attach. And we said, yeah, we can design. So we designed the whole system, and this guy started looking for the installer. And because this drop was too small and they couldn't find anyone, And we said, okay, we can help you. We just provide you the whole set of shop drawings with the layout of the wall brackets, the rails, and also we can draw all the panels and layout of the screws that we can send for prefab all the panels. And when we've done it, send the full size they bought the panels, send it to fabricator who cut it all the panels, and then they arrive on site. We send all our materials on site, and they put it all together like in a week. And then on the next slide, you can see it's the very good job they done by excavation company, not the cladding installer. So what I'm trying to say that having the proper set of shop drawings, we can help installer to get nice results and with the short time, because they don't have to think about, because we thought about before and lay out all the clips and everything, and we can design all the details so they can just follow the drawings to install all the cladding materials.
So, what is next? We are intending to write an ebook on optimizing facades, and we'd love to hear about what your challenges are and things that you're curious about, so we could address those. So you could help guide us also on our next webinar. So, our Facade Systems Inc. and U-Kon.ca, we will have our emails up in a moment. We're also happy to review a project. Maybe it's just a case of learning. Could be a project you've done already, or it could be a project that's in the queue, to help you just share some ideas under no obligation. We take the investment of getting up front with projects because we think it's the right way to do, and frankly, it's a way for architects and owners to see what we can do. We hope that what we've done is set some expectations today on the right way of doing things, and of course, maybe learn a little bit about us. So there's the ugly duo, and our I covered Alex's email address, but we'll get those out, and we would be happy to engage with you on your next project. I do have a couple polls, one more poll, and I'd appreciate your feedback, and then we'd be happy to stay here for any questions that you might have. So if you don't mind giving us a little bit of feedback, we appreciate it. We're not looking to be dished good answers. We're looking to understand what best we can do.
Blair, do you want to share the shop drawings?
Oh, geez, yeah, that's a good idea. I'll wait till this poll is done. I think what we're going to show you, everybody, if you can hang on, is I'm just going to wait for a couple more, is some examples of shop drawings. Thanks, Alex, that was good. I'm just going to close that. I'll share that back in a moment. And one moment, please. Okay, there you go, Alex. Tell me what page you want. So this is an example of shop drawings for a project. Is it underway or it's been done?
I think it's already finished in US. It's
Okay.
I mean, it's a small project, but it doesn't matter. We all our shop drawings that we're doing the same way. So if you can just quickly jump from page to page, I will quickly explain. So we kind of shows like a general idea what is like cladding assembly we have on the project. The next on the next page we show the typical spacing on the wall brackets and how we have to attach, what kind of attachment method we have to use, what kind of anchors. And on the next, can you go next? And the same as here, so it's kind of a different anchor system. Actually, we use stone panels, which is 36 38 millimeters thickness, and we use like a kind of approach slab to slab, which is like almost 10 feet along the vertical rail. On the next, if you go next, so on this we show the elevation, and we show the location of the wall brackets and spacing in between, horizontally and vertically. So the installer can just follow the design. Then the next page we show the layout of the vertical rail and the size that we have to cut. So the installer also can use these drawings to cut the rails on site based on the dimensions, so he can slightly adjust it if it's a little bit off from the actual building. And on the next page, you can show we're showing the actual layout of all the cladding materials, like cladding panels. And then on the next several pages, we just show all the different details, like a plan view, section view, or how we can make some window detail, etc. So this is kind of our approach that we try to achieve and present all the information for the project so that it can help architect and the installer design and build it faster and easy and simple.
So
and also we can do some suggestion for the fabrication of the panels.
Right. I don't know how many sets of shop drawings you have had, but 13 pages for a project of roughly that size is exceptional and comprehensive, and that's what we are talking about. Okay, I'll just, I'm going to thank you for that poll, and I appreciate the chance to, I got one more to ask you. Where did my polls go? Okay, so I'll share this poll first of all. So thank you. I'm happy to learn from the folks that were in the 3 or 4 range. I'd be happy to receive an email of how we could improve it. I greatly, I'm really here to learn. And I'll do that. And then I've got one other question for you, please. And we still have 93 people out of the I think 107 that signed on, and we greatly appreciate you hanging in there for the whole thing. We learn a lot. So somebody's inviting us to explain the rain screen cladding, and we'd happy to do that. What is the spacer, Alex? I think I know the answer, but you answer it, please.
The material or the thickness?
We'll say both.
Okay, so the thickness, it's the 10 millimeters, like 3/8, and it's a plastic poly vinyl chloride, PVC.
I saw something about, okay. Currently design owner switch to cast in place. Well, I guess I'd have a chat with you, understand what is cast in place. If it's the structure, then we can obviously attach rain screen. So I'll close that poll, and thank you very much for sharing your answer. Greatly appreciate it if you did share your experience here with your colleagues. I think what we're going to decide, because of the number of people that have been interested, is that we are going to do this again. So you'll see announcements of that shortly. The recording and the presentation will be available on our website and U-Kon's website probably by tomorrow. So I think we'll call that adieu, and Alex and I will stay here on the phone for another 5-10 minutes to see if you have any more questions. So thanks again, and thanks for hanging in there for the whole event. I really appreciate it.
Thank you everyone. Yeah, if you have any question, let us know, like we'll try to answer.
Question was about certificates. Yes, I will be taking, for the folks that attended, you'll receive a certificate maybe by the end of the week or into next week. It takes me a little process to do that. Thank you for a nice couple compliments. We greatly appreciate it, your support. Okay, well, we'll wind that up. Thanks again. There's several nice thank yous, and I really appreciate it. Feels great to do these things. And we're glad that we're helping out with advancing the cause. Our objective is to leave the industry better than when we got here. So thanks very much. We'll end today, and we'll see you on the next one, or give us a call. Thank you very much.
Thank you. Bye-bye. Have a good day.